Hello, probability and statistics students. Today we're going to be taking a look at a second example related to sampling distributions for a sample proportion. And before we go through that example, I wanted to remind you that there are three conditions that we need to check before doing any calculations related to sampling distributions for a sample proportion. And I've circled or boxed the items in green. So we always want to make sure that we're working with a simple random sample. And sometimes you're not sure if you have a simple random sample, but hopefully the organization that gathered the data used random methods to gather their data, whether it's a simple random sample or a stratified random sample. We also need to make sure that we check the 10% condition, that we want to make sure we're sampling no more than 10% of the population. That allows us to use this formula for calculating the standard deviation for the sampling distribution of the sample proportion. And we also want to make sure that we have a sampling distribution that's approximately normal, but that would only happen if we have at least 10 successes and 10 failures. That's what this calculation is showing down here. So let's take a look at the second example, the one that's on the back of your notes. So in this example, the superintendent of a large school district wants to know what proportion of middle school students in her district are planning to attend a four-year college or university. Suppose that 80% of all middle school students in her district are planning to attend a four-year college or university. Maybe that's based on data from a previous year, or maybe that's based on a national average, but they have this hunch that it's 80%. What is the probability that a simple random sample of size 125 will give a result within 7 percentage points of the true value? Well, before we do the probability calculation, let's actually make sure those three conditions that I mentioned a minute ago are met. First of all, do we have a simple random sample? Well, here it says a simple random sample of size 125, so simple random sample is stated. Next, have we sampled less than 10% of the population? Well, if our sample size is 125, that would mean that we'd want to have our population be at least 1,250 students. And at a large school district, it would be reasonable to assume that a middle school would have more than 1,250 students. Next, we need to make sure we would have at least 10 successes and 10 failures, or that we would expect on average, when we do a sample of 125, that we'd have 10 successes and 10 failures. This will allow us to use normal distribution calculations. So if I do 125 times 80%, I get 100, and 125 times 20%, I get 25. Both 100 and 25 are more than 10, so we would expect to have, on average, 100 successes and 25 failures, meaning 100 students saying they were going to a four-year college or university, and 25 saying they're not attending a four-year college or university. So we've met this condition. So now let's talk about our mean of our distribution and our standard deviation. We know that if the true percentage of students that are going to a four-year college is 80%, that if we took a sample of 125, we might not get exactly 80% of the students saying that they're planning to attend a four-year college. It might be a little bit more, or it might be a little bit less, but we would expect it to be centered at 80%. And this is the calculation for the standard deviation for the sampling distribution of a sample proportion. And the next thing we would do is always to draw a picture. So here's our picture. A normal distribution centered at 80%. And remember, the original question was, what's the probability that a simple random sample of size 125 will give a result within 7 percentage points? So within 7 percentage points of 80% means we would want to be within 0.73, that's 7% less than 80%, and 0.87, that's 7% more than 80%. So basically, we know that when we do a sample of 125, we will probably not get exactly 80% of the students saying they're going to a four-year college. It might be a little bit more, it might be a little bit less. We're wondering what percentage of observations would fall within this range. So we could calculate the area in each of the tails and note that they're symmetric because we have a normal distribution here, and then subtract that from 100%. So we could actually calculate the z-scores and use our table and do some work that way, which we'll talk about in a moment. However, you might note that our standard deviation is about 3.5%. And so if we go out 3.5% and another 3.5%, we've gone out 2 standard deviations from our mean. And if you remember our 68, 95, 99.7 rule, 95% of our distribution for a normal distribution is within 2 standard deviations. So actually, if you recognize that, you would not even have to calculate a z-score or use the table. We could simply say that assuming 80% of all middle school students in the district are planning on attending college, 95% of the time, oops, this should say of the time. Let me fix that there, if I can. Maybe not. There we go, of the time. A simple random sample of 125 will give a result within 7% of the true value of the population proportion. So, assuming that that is the true value, 80%, 95% of the time will be within 7 percentage points. So we'll have gotten a pretty good idea of what the true value is, or be within the true value. If you wanted to, you could actually do the z-score calculations, as I mentioned earlier. Let's see here. There's our z-score calculation. The value of 73% minus 80% divided by our standard deviation would give us a z-score of negative 1.6. And then if we look up the probability on the table, we would get the area in this tail is about 2.5%. So the area in both tails combined would be 5%. So 5% of the time we'd be more than 7 percentage points from the true value, and 95% of the time we'd be within 7 percentage points of the true value. You may need to watch this video again to make sure that this makes sense to you. Watch it a second time after you've taken notes. It'll probably make a little more sense the second time you go through it, because you'll be focusing on what is being communicated instead of just copying things down. We will have some time to answer questions in class on the graded problem set on this, but remember, the graded problem set is not due until Friday. Have a wonderful weekend.